Okay, thanks everyone. It's great to be here at Nickel City Ruby. So this talk is going to be about me and my own journey as a blind person, and then I'll get into app developing as well and some work I've been doing. So again, my name is Austin Seraphin. I've been blind since birth. I started on an Apple IIe. That was the first computer that had a screen reader. This was back in 1983, 1984, something like that. And the machine still works, by the way. And so that was the first computer with a screen reader. And a screen reader is what a blind person uses. That's how they use a computer. It renders the screen usually into speech. So it reads the screen. So after that, after the Apple II, I moved to MS-DOS. I customized that to its fullest. I used Windows, unfortunately. For Windows, the most popular screen reader costs $1,000. And it's worth noting that there is a free one called NVDA. So that's worth noting for Windows accessibility people. After that, I moved to Linux, which has a screen reader built in. It has Speak Up built into the kernel, and it also has Orca, which is part of GNOME. Then I got an iPhone. In June of 2010, I got an iPhone, and that was really the turning point for me. All of Apple's products have accessibility features built in, including VoiceOver, which is a screen reader, and Zoom, which does screen magnification. After that, I got 2 Macs. And I think for the blind, the Mac gives the best desktop experience. It's great. It lets a blind person use a trackpad for the first time, which is really cool. After that, I also got an iPad, which makes a great media player and book reader. And now I'm pleased to say that Kindle, iBooks, and Nook all work well. They're all very accessible, so that opens up ebooks to the blind, which is just tremendous. A keyboard cover also helps for the iPad. So the iPhone changed my universe as soon as it entered it. The blind are used to getting little to nothing from companies, so we were skeptical of Apple. And blind people kind of made fun of it in the beginning when it came out, and we were just like, this is the stupidest thing. How could a blind person even use a touch screen? So then one day a friend of mine got one and just raved about how much she loved it and how much she loved the touch screen, and I was like, wow, okay. And so I went to the AT&T store with my mom, and I had actually read the manual because I was so excited. So I had an idea of what to expect, but nothing could have prepared me for actually using it. I began using it immediately. I checked the weather. The feature that sold me was that the Stocks app renders stock charts, which is really cool. So for the first time, I could read a stock chart. And then Mom sent me a text message. They didn't know if it could text or not. The people at the stores usually don't know too much about it. But she sent it, and sure enough, it came through, and everyone felt moved. The iPhone really opened up my world. The important thing to note about how it affects the blind is that it makes assistive devices obsolete, a lot of them. The blind are used to paying a lot of money for very niche devices that are just made for the blind. And so that means they're very expensive and often not very well supported. So the iPhone and technology like it makes all these devices, a lot of these devices obsolete. For instance, the first night I came home and I was thinking about just that. And I was thinking about different devices, and I thought, well, there's a color identifier. There are devices that cost $200 that'll identify colors. And so I typed color identifier into the App Store, and it came right up. It cost $2. I installed the app, and it came up, and it just kept saying black, black, black. And I thought, well, maybe this isn't so great after all. And I started, I don't know. And then I realized it was like 2 or 3 o'clock in the morning. I didn't have any lights on, and yeah, you need light to see color. I forgot. So I turned on, and there were all the colors, and that was really an amazing moment for me. That's really when I knew it. And an interesting point about that app is he didn't write it for the blind. So that shows you why accessibility can be so important. There's a light detector app that costs nothing, a simple light probe. That can be handy. There's an app for reading currency. You can buy a device just to do that for $100 or spend $10 or less on an app to do it. There's object recognition. There are devices for $1,200 you can buy, or apps that you can get for free, like Tap-Tap-See, that help with object recognition. For instance, if you have a box or a can of something and you want to know what it is, point your iPhone at it, use the app. tells you what it is, and it's really incredible. GPS, there are many GPS solutions for the iPhone now. Standalone ones cost around $800. There's an app now, Sendero Group is a popular one. The one I like is called Blind Square. It costs $15, and I like it because it hooks into Foursquare's database of locations, so you get a very up-to-date sense of what's around you. There are other examples too. A scientific calculator costs $250. You could get an app for $5. An alarm clock, you could pay $40 for a talking alarm clock. That, of course, is built in. A note taker, this is a great example. There have been devices for years, standalone note takers for the blind. They now cost around $1,000 and do all the basic note-taking function and address book and all that stuff. And now there used to be a really good one called the Braille and Speak, but they're just terrible now. And of course, the iPhone has all that basic note-taking stuff in for free, and with a much better web browser as well. There's so many other cool apps for the blind. A cool one is Flexi, and that lets the blind type like the sighted. You just type where you think the keys are approximately, and it figures out the words that you want. It's pretty cool. So if you total all this up, that's $3,600 in assistive devices versus $232 for an iPhone, assuming you can get it on a subsidy, and apps. So we could call it an even $300, get a Bluetooth keyboard, since they're nice to have. So call it an even $300. So that means that a blind person would spend 12 times more if they wanted to buy all of those assistive devices. Accessibility really helps everyone. There are a lot of great mainstream examples of this. A good one is Siri. Sighted people now are all excited that their iPhone can read them their text messages. And I'm saying, yeah, it is cool. That's how I do everything. And, and the same is true with audiobooks. The blind have been reading books for decades, and now they're popular with sighted people. So accessibility really ultimately helps everyone. There are many examples of that. Even little things that sighted people take for granted, like reading a menu at a restaurant. There are apps that can help with that. So VoiceOver is really cool. VoiceOver is the screen reader that's built into Apple's products. It now supports speech, Braille, as well as the click controls for people with motor disabilities. So from a developer standpoint, that means if you use these APIs, you've made your app available to 3 distinct groups of disabilities: the blind with speech and Braille, the deafblind with Braille, and people with motor difficulties with switch devices. So if you want to try VoiceOver, you can go to Settings, General Accessibility. It changes the gestures, so I wouldn't recommend just trying it. Now, it's really cool what Apple's done here with VoiceOver, because they've combined a 2-dimensional and a 1-dimensional view. They've really done a revolutionary thing. So the thing to understand, the way I like to explain this, is a screen is a 2-dimensional output. It's got your width and it's got your height, or rows and columns. And audio is a 1-dimensional output. It's a line. And so a screen reader has to translate a 2-dimensional output into a 1-dimensional output. That's ultimately the challenge. And so with Apple, with VoiceOver, you can move your finger around the screen to explore the icons under your finger. It'll read those. And you can also swipe to the right with one finger to go to the next element, and to the left for the previous. So those are your 2-dimensional and 1-dimensional views, and that's why it works so well. You double tap anywhere on the screen then to activate the item. You can swipe up and down and use the rotor if you want finer resolution, if you want to read by character or word or heading or things like that. And you can scroll with 3 fingers. And that, believe it or not, is all the basics of how to use VoiceOver. So it's really simple and amazing. From a developer standpoint, again, the cool thing is that all the standard Cocoa elements work by default. So if you're using the standard controls and you're labeling those controls well, then you've done 90% of the work. And Apple does have guidelines on their website. So that's kind of the basics of that. Now I kind of want to move into Rubymotion. Rubymotion, since this is a Ruby conference, is a tool chain for developing iOS and macOS apps. It is a commercial product. It costs $200, but I'd probably spend that on beer if I had to use Xcode and Objective-C. So I think it pays for itself. Rubymotion apps are fully App Store compliant. It's a compiler. It's not an interpreter. It's based on Mac Ruby. It uses Ruby with all of its advantages. All of the SDKs are available, so there's no restriction there. You don't need to know Objective-C, but you do have to know it enough to interpret it, so you can use examples that you find online or talk to other developers, because it just translates right over. Rubymotion also does have translated docs. You can use the Dash document browser, which I'd recommend. It's built on top of standard Cocoa classes, so object is now NSObject, and string becomes NSString, for instance. It handles memory management, which I consider a real plus. It has command line operation. You just use the standard Ruby tools. You just use rake and gem and bundler and all that good stuff. It's all right from the command line, so for the blind, it's awesome. It also has unit testing. Rubyists are big on unit testing, and it brings that to iOS, leveraging the UI automation framework. The really cool thing about that, by the way, is that writing functional tests improve accessibility. You can say tests in a view controller, and then you could say tap and then the name of a button, and it will use the accessibility label to figure out what button you mean. And as I said, that's probably the biggest complaint is unlabeled buttons. So it's really cool that that helps you label your buttons properly and helps you write software tests, which you should be doing. Another great thing, of course, is the REPL. Ruby has the REPL, the read eval print loop, where you can enter Ruby at a prompt, and Rubymotion has that as well. It runs the simulator, the iOS simulator, and then you can write Ruby at the prompt and interact with the running application. When things get heavy, you can also use the Rubymotion debugger. It was based on GDB. Now, as of iOS 7, it's based on LLDB, and it connects to and introspects Rubymotion processes. And you can also use that on a device, which is really cool. And the developers do plan to add that to the REPL. Rubymotion has a lot of great open source gem snaps. This is one of the things that makes Rubymotion really awesome. It's not just porting iOS. There's a whole community making these really cool gems. For instance, gems like Bubble Wrap and Sugar Cube give more idiomatic code. For instance, if you have a button, you can say button.when and pass a code block. There's persistence. There's JSON support. Lots of goodies just made really easy. GeoMotion makes geometry easier. I really like that, iOS geometry. That's really what helped me finally understand iOS geometry and give me that aha moment that I was seeking for learning to write apps. It has a nice cgvector.make syntax, for instance. It also has methods like below and beside, so you can just lay out views very easily. Teacup is a DSL for style sheets. That's really cool. You can specify percent, so you could say like width 50% or something like that, and it'll just figure it out. And I say the less pixel math, the better. I think we can all agree on that. Formotion lets you do forms. You just pass a hash to it, and it just whips up a nice form for you. Motion Model offers simple model validation and input mix-ins. Promotion is really cool. That lets you easily lay out apps. Motion Bundler lets you use most standard Ruby gems. For a long time, people wondered if you could use standard gems with Rubymotion, and now you can use most of them. So that's a little bit about Rubymotion. I think it's really cool. The website's rubymotion.com, by the way. So now I want to get into app developing for the blind, because, of course, as soon as I experienced the change the iPhone could make, being a programmer, I thought I'd need to figure out how to program this thing. It's just so cool. And I tried learning Objective-C and using Xcode, but it just wasn't happening. I just posted a random thing on Twitter, said, I really wish I could write apps in Ruby, and someone said, yeah, try Rubymotion. So that's how that all started. So I get more done in Ruby. This is kind of subjective, but I think Ruby sounds better with speech. Its syntax, I think, just sounds more natural when you're actually having it read aloud to you. Xcode, as I said, works horribly. Give me Emacs and Ruby in the terminal any day. Interface Builder has no accessibility. That's not too much of a surprise to me, but that's how a lot of people lay out their views. So that means that I had to learn how to build all the views programmatically, which is fine by me. I think of views of the screen either as views relative to each other or as views positioned absolutely on the screen, so GeoMotion and Teacup, as I said, both helped with that. So now we come to motion accessibility. And this is a gem that I'm going to show off to you now here for the first time. And I'm really proud to say Motion Accessibility 2.0 is online right now. You can get it on GitHub or on Ruby Gems. So I guess we'll switch over to my laptop here. So while we're getting that set up, I'll say First, I just wrote some simple wrappers around the UI accessibility elements, and my thinking with that was anything I can do to give developers one less excuse not to do accessibility is a good thing. So first I made the UI accessibility protocols more Ruby-like, and then I started writing some simple games and some apps to try to get the hang of it, and I quickly realized a problem, and it was something that Laurent, the creator of Rubymotion, told me about when I first started using it, and that is that he was worried about the iOS simulator. And I knew that going into it, that the iOS simulator does not work well with VoiceOver. So it was a challenge I knew that I would have to overcome somehow, and this is how I've done it with the Motion Accessibility console. So we're going to show that to you now.
Awesome. Do you want to plug in?
Yeah.
Okay. Good.
We're good? We're cool?
Yeah.
Okay, so what we're going to do here is we're just going to type rake, and it's going to open up this little test app I wrote to show you the basic workflow of how Motion Accessibility Console works. So this is called the Motion Accessibility Console, and I'm taking advantage of the fact that the REPL, as I said, will let you interact with the running application. So it's, and there it is. There's our test app. You can see this first tab has a label. It has a text label and then a text field, and you can enter text into the text field, hit the update button, and it changes the label. So a very simple thing. It's not going to win any awards, but it'll show you the basic workflow. So the first command is browse, which you can shorten to B. And there you can see a textual representation. It says browsing UI window, and then it says 1, UI label hello, 2, touchable UI text field, 3, touchable UI rounded direct button update, and then we've got our UI navigation bar and our UI tab bar. So, by the way, one thing I'll just quickly show you is the view command. View or V will show you the either current view you're browsing, or you can specify a view. So let's touch the text field. Let's say touch 2, and then hello, Nickel City, Ruby. And there we can see that it's updated there. And you can see that the text field has also changed. Now you can use what's called the accessibility label, and I'll talk more about that in a second, to refer to a view as well. So I can say touch update, because it knows the button's called update. What? Oh, what should I do?
I can close it.
Okay. Sorry about that. So.
Aren't demos awesome? Yeah, come on.
Yeah, I know, yeah.
Okay, now you're good.
All right. It's telling me I need to download things.
That's the App Store.
Oh. I know, I hate it how it steals focus. It's very un-Apple-like.
You're good.
I'm good. All right. Come on. Let me do my thing. All right. Here we go, folks. So now you can see that I've updated it there, and you can see there in the simulator that it's done the same thing. It's hit that update button, and there it is. So now let's do something a little bit more complicated. We're going to go into the tab bar. So we're going to say browse or B5 to go into that, because it has 2 subviews. And now we see the tab bar buttons. So we're going to say touch 2. Now this is going to actually update the screen. So it's going to monitor for this in real time. And there it is. And it's telling us we have a UI table view with 11 subviews. So there you can see that in the subview. In the simulator, it's just a very simple thing. It's a table of alphabet letters, and when you touch one, it'll tell you the phonetic representation of it. So let's touch 5 and see what happens. And now you're going to actually see, and it just crashed. Oh no. Oh. Sorry. We have to browse into the table. No big deal. There we go. It didn't crash. All right, so now there's the table, there's the table, there's the table. So we hit touch 5, and there we go. And now we're going to see it update with the label. And there it is. So now I want to show you something else. If you browse something that doesn't have a view, or you can also call the inspect accessibility on this, it'll bring up the accessibility inspector. And you can also call inspect accessibility on a view. And so here are all the different attributes that you can set. So it tells you it's a UI label. The accessibility label is the most important thing. That's what I was talking about earlier, about how it can find views. The accessibility label is the basic element that VoiceOver reads to you. So if you're a developer and you want to take one thing away, it's that. Set your accessibility label. And all this applies to Objective-C also, by the way. This isn't Rubymotion at all. These are Apple's accessibility APIs. So there's the accessibility label. There's the accessibility hint, which is something a little bit longer and more verbose if you need that, if a control behaves in a non-standard way. There's the accessibility traits. Now this is really cool. Here it sets a static text because it's a text label. There are a bunch of them. There's static text, there's button, there's image, there's link. There are a whole bunch of different ones. There's one to tell it it's turning a page. There's one to tell VoiceOver that you're about to play media. There's one to tell VoiceOver to be silent because you're recording media. There are a whole bunch of really cool traits that you can set for your views to tell VoiceOver exactly how to do it. So you can make even the most custom view totally accessible. There's the accessibility value. That's for sliders and things like that. VoiceOver will report that. The accessibility language is the language VoiceOver uses. The accessibility frame defaults to the frame of the view. The accessibility activation point is the point that VoiceOver simulates tapping. I said you can double tap anywhere on the screen. When you do that, VoiceOver does the activation point. There's accessibility views modal, which will tell to ignore other views on the screen if you've got a modal view, popping up over other things. Should group accessibility children is for usually VoiceOver reads horizontally and then line by line, which usually is what you want, but sometimes it isn't. If you set that to true, it'll respect the order of the views in your subviews array. Accessibility elements hidden hides the accessibility elements that are under it, and is accessibility element tells VoiceOver to regard it. And that's an accessibility identifier. So that's basically how motion accessibility works. That's what it's capable of doing now. You can get it on GitHub. And so I can turn that back on. And so that basically gives you a really good idea of the basics of how VoiceOver works and a little bit about how you program for it. By the way, if you're interested in programming the views, you can specify those attributes. Either you can define methods and put them in your custom subclass, or you can just specify them as setters and just say, for instance, view.accessibility_label equals whatever. So they're very easy to set. And once developers learn them, they can make anything really accessible and give a great experience in iOS. So that's kind of the basics. The blind really benefit from the iPhone and allows the blind to do wonderful things. Rubymotion increases productivity for the sighted, and especially for the blind, and it'll only get better. It is a great community. In most cases, developers can make their apps accessible with little effort. Accessibility helps everyone. It's the right thing to do, and if Apple wouldn't have made their iPhones and Macs accessible, I wouldn't stand here now giving this talk. So thanks a lot, and I'll open it up to Q&A now.
All right, I think we do have some time for some Q&A. So does anyone have any questions for Austin?
I'm just wondering if you've had a chance to play with Android and how its accessibility works.
Oh yes, I did recently get a Nexus 7, and I've been playing a little bit with Android. Yeah, Android's come a long way. They have a screen reader called TalkBack, and they actually used the what I was explaining to you about the tapping and swiping and double tapping. They totally ripped that off, and with good reason. Microsoft did also, and it's a design that works. So it uses that. It has a few other gestures which I'm a little less enthusiastic about, but yeah, it's come a long way. It still has a ways to go. It's not, quite as polished as Apple, but yeah, it's there now.
Any other questions? I have a question.
Okay.
What's the best thing sighted people can do to make apps better for the blind?
Well, as I said, you use proper accessibility labels. Make sure VoiceOver knows what kind of control it is. And if you're talking like web accessibility, it's kind of a similar thing. Use standard markup. Use things that are designed to do. If it's a button, make it a button. If it's a table, make it a table, and so forth. People try to do fancy tricks and things. Standards exist for a reason. Yeah, I mean, it really, a lot of it, as I said, comes down to good design and just doing things in the right way.
Cool. All right, thanks, Austin.
All right.